Hello, students. As I promised, I have brought you another video, and this is precisely for mathematics, for your preparation for class 10 board, right? So I'm going to teach you how to prepare a mind map, intensive mind map for your revision for the board exams. This mind map may not be so much systematic and organized because this is needed only for intensive preparation. It should be correct only. It may not be decorative, right? I'm going to tell today the idea by which you can really make the effective mind map, which will really help you for the exam preparation as well as to retain the informations. As I promised, I'm going to prepare one mind map in front of you, right? I'm not doing it through the tab because it will not be effective. It may not be like motivating. I'm just doing it the way you can do it at home, right? So let's get started. I'm choosing that particular chapter where maximum informations are there because then the mind map can be well explained and small chapters you can do. And after that, also, if you feel that a particular chapter's mind map is needed, you can tell me, I can prepare, I can help you to prepare it, right? So let's get started. I'll take linear equation in two variables. Let me share the screen. Yes. So linear equation. See, as I told you earlier also, that I'm not going to prepare a mind map which is very systematic. I have to only recall the informations. That is the only idea, right? And this mind map you prepare once you revise the theory parts, right? Then you will be able to understand how much you have retained, and that will definitely help you to scrutinize yourself. And that is one of the biggest job you have to do before you go for your board exams, right? So I'm not writing linear equation in two variables or pair of linear equation in two variables. That is not required here because you're not going to show it to someone else, right? It's your property now. So I'm preparing it for you. So there is some problem in the shadow. Actually, my lighting in the room is not very good. So please adjust it. Okay, this is the linear equation in two variable, right? So immediately, when you are talking about a linear equation, what should be coming to your mind immediately? What I feel you should remember the standard equation, right? So very immediately you will write the standard equation. Standard equation of a linear equation, I'm saying, not pair, remember it. So linear equation standard form is ax plus by plus c equal to 0. Okay. And then there are some important conditions. I don't know whether you are remembering or not. It will be a linear equation in two variable provided a square plus b square is not equal to 0. Not equal to 0. This actually indicates that at a time, both A and B cannot be 0, right? So this is the another point, which is giving you the idea of linear equation in two variable. See, you are doing linear equation in two variable, it is okay, but you should start revising it from the basics. Then you can change the color of the ink, right? It will be helpful for you to keep the concentration intact. Okay, what do you know about this now? Try to make it. Okay. What I know, right? One is that it has how many solutions? Infinite solutions, right? Infinite solution. A linear equation in two variable has infinite solution. This is what I know, right? Secondly, what I know from here again, graph is a straight line. Graph is a straight line. There is a graph which will be a straight line, right? Then what is a link between solution and the graph or the points on the graph, right? So here you can write again every point. I'll change the color. Every point on graph, every point on graph is a solution, right? That means if you draw the graph, every point on the graph is a solution of the linear equation. And conversely means, what do you mean by conversely? That is in the reverse direction also. That means if you take a solution, that will be always a point on the graph. This is what we got from our last class, that is class 9. Now you are studying pair of linear equations. So pair of linear equations means what? Name itself is suggesting pair of linear equation means two equations at a time. So here I have introduced this. Now here I'll write, right? So I'm going to write two different equations. So I'll write here pair. Simply I'll write pair. That means I'm going to talk about the pair of linear equations. So what are that? So if you're writing pair, that means you should have two different equations at the same time. Two different equations at the same time, right? So a to x plus b to y plus c to equal to 0. So this together is giving you a pair of linear equation. Got it? Now here you see, as we have written already this condition, a square plus b square not equal to 0. This same condition will be true here also. So we are not writing it. Just you think about it, that this is valid. Okay, now just try to connect it with what you know already, right? So you already know that every such linear equation in two variable gives you what? A line in the graph. So there are two linear equations. So how many lines do you expect? Two lines, two straight lines. So we have gathered these informations. Two lines. Very good. Two lines. So two lines can be of what nature? Now you will be getting three different options. You will be getting three different options for those three lines in plane, right? What it can be, draw it with the help of figure. One can be of this sort. That means the lines are intersecting. This is one of the possibility. Then what? You can get two lines which are parallel. And you can get one more third condition where the lines are actually overlapping. See, I'm doing with the same color. So two arrows I am putting to indicate that I am doing with two lines. So these are the conditions. These are the possibilities. Okay. Now let us explore what are these talking about. First of all, let us name them. Name them. The first one is intersecting lines, right? So this is intersecting. Intersecting. Second one, okay, it is parallel. Okay. And the third one is coincident. Coincident. You should take little bigger paper. My paper is smaller here. A4 size, even then it becomes little smaller. But otherwise you will write small size letters. So we have got these three things, right? So what we got, again, I'll try to revise it, right? These are linear equations in two variables. Two equations are there. Then I get two lines in the graph. Try to create the image in the mind. Then I'll be getting these three conditions: intersecting lines, parallel lines, and coincident line. Coincident line means I can say overlapping line also. Now, we are going to really get the idea of the solutions. That is very important now. So how will you get the solutions? Can you recall? See, I would like to again try to tell you the point which already we have marked out. this every point on the graph is a solution, and conversely. So now here you try to see this. Figure is telling you, remember it. So give more importance to the figure. You will understand everything. These two lines are meeting at this point. So this point is the common point. This is lying in this line as well as in the second line. So this common point is the common solution of those two equations, right? So there is only one common solution. So here we'll write one solution. One common solution. That common solution is known as the solution for pair of linear equations. So one solution. Acha, one solution. One solution is termed as what? It is unique solution. Unique solution. Unique solution. That means if the lines are intersecting in the graph, the equations will have one solution. That is unique solution. Good. Then we'll come to the parallel. Look at the line. Parallel. How many points will they intersect? There is no point of intersection. There is no point of intersection. There is no common point. It means you are not going to have any solution, any common solution for these particular equations. So we'll write this as no solution. This is the situation where no solution occurs. No solution occurs. Absolutely. Okay. Now we are going for the last, right? No solution. So we don't have any name here. Now you go to the last. Last, I don't have much space here, so I'll take the arrow that side. So I'll write here. I have got coincident line. Coincident line means lines, all the points are common. Infinitely many points are common. So infinitely many points are common means infinite solution. Infinite solution. That means if the lines are coincident in the graph, how many solutions you can get? Infinite number of solutions, right? So before you go for further things, again you quickly review. Repeatedly if you do, then informations will be complete. This is called repeated revision. I'll explain that also one day. Lines are intersecting, one point, then unique solution. Lines are parallel, no intersection, they are parallel, so no solution. Lines are overlapping or coincident, so infinite number of solutions. So these are graphical ways by which we can identify. Now, definitely, there are certain coefficients A1, B1, C1, A2, B2, C2. We have to relate them with these conditions also. So now, if you want, you can write separately, but if you try to drag it here only, then it will be always good because you will be getting the informations in the chain. You will not forget, right? So here you have to recall for unique solution, what was the condition, right? I'll give you also one more thing to remember, how to remember these things. Now it is A1 by A2 not equal to B1 by B2, right? This is the algebraic conditions which will tell you that the equations, the linear equations will have one solution or a unique solution. And in turn, it will give you intersecting lines in the graph. Good. Next, no solution. No solution is A1, A2. They will be equal to B1, B2, but it is not equal to C1, C2. So this is the second condition for parallel lines. Very nice. Now, the last one. What I should get for infinite? For infinite, it is the easiest one. A1, A2, B1, B2, and C1, C2. They all will be equal. Quickly again, you revise. First thing, when the first two ratios are not equal, it is unique solution. Unique solution means lines are intersecting and you can come down in the reverse direction. First two ratios are equal, third is not equal. No solution, that means lines are parallel. Graph will be looking like this. Last one, coincident, then infinite number of solutions, and the condition is A1, A2 plus B1, equal to B1, B2, equal to C1, C2. All the ratios are equal. So you are doing a great job till here, because these are the conditions where many problems will be coming. Okay. What else you now need to recall? Let me try to recall the method of solutions, right? Of course, method of solutions, we may not write here because without the problem, we cannot write. So I'm just writing like this. So we'll talk about the pairs, right? From pair, because we are talking about the method of solution of linear equations in two variables. So method of solution. So what are the methods? Actually, there were three methods. We had three different methods, but CBSE has removed the method of cross multiplication. So we'll be having now only two methods, right? One is substitution. Another is elimination. Now try to again immediately recall both the meanings. You now know, acha, one more thing is there. This is the algebraic solution, right? There is another one, that is graphical. So graphical is very easy. Why very easy? Because you have to draw the graph and then you have to compare which particular situation out of this is there. So accordingly, you see, if you are getting intersecting line, that point you have to read from the graph. Solution is obtained. If parallel, no solution, nothing is to be found. Just comment will be there. If coincident, infinite solutions will be there. You cannot write all. So you just write that infinite number of solutions are there. So basically, once they will be giving you graph, two conditions are more likely to be given. One, intersecting, if they will ask for the solution. Other one, where solution will not exist, right? So this is done. Now, you try to again put more emphasis on your idea how substitution method is done, right? So substitution method, you may not try it extensively, just bring it to your mind, thought process. Just I am writing a keyword that will remind me of what I have to do, right? Substitution means to replace, right? To replace. So that is a keyword for me. To replace, whom to replace? You will either replace X or you will replace Y. And then you will make one linear equation in single variable and you can solve it, right? And elimination means to remove. To remove. Whom to remove? One of the variable you have to remove by making their coefficients equal. So that is the process. Keywords. This is the keyword, right? So more or less we have covered almost all the parts. Have we forgotten something? Just try to recall. Have we forgotten something? Did we miss out anything? So after preparing the mind map, otherwise mind map is completely ready. So did we forget anything? See, we are going to infuse something more here because we are going to collectively revise everything of linear equation, whatever we can remember, right? So you fill the pages by informations, whatever you know. Till now, I think we have covered everything here. So now we'll go out of this mind map. We'll try to write some information, some more information here only, so that this simple page will be very informative for me and I can revise the entire linear equations in the same sheet, right? So this is here over. Now you try to recall those important informations, remember it. Two-digit numbers, right? So you write two-digit number, right? Two-digit number. Two-digit number will constitute of what? One is tens place, and another is ones place or units place. Then what will be the number? Then the number will be what? Tens place whatever digit you consider. So I'll not write here y, x, etc. I'll just write 10 into which will come tens place digit whatever is there plus 1 into units place digit whatever is there. Now in particular, if you take x for the tens place digit, y for the units place digit, then number will be 10x plus 1y, that is 10x plus y. So this is a good revision. You can recall this. So you mark it, right? Okay. Then what else? Very confusing. Very confusing. Upstream and downstream. Okay. Draw a figure like this. This is upstream. Upstream means, sorry, upstream I'll not write. This is the current. First I'll write this. This direction, the current is there, right? If water is flowing this way, if wind is blowing, then this way. This is the direction of the current. And if you go this way, upstream I have already written, so I'll not cut it. I make it reverse. If you go against the current, right, flow of the water, then you are going upstream. But if you are going in the flow of the water or flow of the or direction of the current, then this is downstream. So this is to be understood. So upstream means what? You are going against. Downstream means what? You are going for the motion, along the motion. So if you are going along the motion, you will definitely get help, right? For the current, you will get a pushing. So your speed will be increased. Now you see, if I say speed of the current is y kilometer per hour and usual speed of yours is x, in the downstream, your speed will be increased. So it is x plus y. Remember it, I am telling x plus y. Yours will be increased. And in the downstream, yours will be reduced. It is x minus y. I am not writing the unit here. Kilometer per hour will be there. Very important thing, right? Now, if I reverse the situation, that also you were mentally prepared. Think about that. If current is having speed x kilometer per hour and your speed is y, usual speed, then what will be the speed in the downstream? It will be y plus x, not x plus y plus x, because your speed will be increased. And the upstream, it will be y minus x. Your speed will be reduced. It is not x minus y, because students are of this habit. They directly write always x minus y for upstream, x plus y for downstream. Be very alert about that. Understand that fact. So this is about the upstream informations we have collected. Is any more informations to be done? Yes, right? About the age problem. Age, right? Supposition should be what? Supposition should be what? Supposition of present age. Remember it. If you have to somewhere consider, always the reference is the present age, right? Whatever age you consider. For example, if I ask you what is your age, you will never say, sir, my age was 10 years before 3 years. You will not say like that. You will say today's age, present age, right? So whenever you make a supposition, always your supposition is for present age, for 99% problem. Some exceptions may be there. Then what more? Speed and distance problem, you can never avoid this. Speed equal to distance by time. I don't know why students get confused, because this is the only single formula which will be used. So अब इसको तोड़ मरोड़ते रहो. You make the different forms. So what you can write, if you multiply speed into time equal to distance, this is another form. And if you want to find t, then expression is distance by speed. This is the another. So any speed and distance formula problem, you can never avoid these particular informations. So this way we have exhaustively taken all informations except one. Now I have remembered actually two very important words were there: consistent and inconsistent, right? So how I'll write, you see, we have written here method of solutions, right? So I'll write here only pair of linear equation is here. So from here I'll write, right? Two arrows will come out. Solution exists means solution is there, then the equation is called consistent system. And then if no solution, then simply inconsistent. Now you see, you have now the ability to connect this inconsistent and consistent to the given algebraic conditions. Let us go back. We'll find here. Is this the condition of consistency? Yes, because we have one solution. So it is consistent. That means if a pair of intersecting line is drawn, they represent a consistent system of equation. If I'm talking about parallel, is it consistent? It is not consistent. Why it is not consistent? Because it has no solution. This pair has no solution. And last, infinite solution is there. So what do you think? This is also consistent. So you can now identify that under the word consistency, there are two conditions: one unique solution, other infinite solution. And for inconsistency, one is there, that is parallel lines. That means no solutions. So my camera range will not cover the complete page. It is looking very nice, but I'll show you part by part. This is the thing. And our center starts with this. And then we have jotted out all these informations. Now you see, if you keep this page for few days till the exam gets over, and you see just for 5 minutes these things, once you prepare, then you can really revise all the informations quickly. And then you will be always ready with these theory parts. Next step is to solve the problems that I'm not going to do here, right? So, but at the last, I want to again tell you that you do it, and after that, make sure that you check the validity of this. Because by chance, if you write some wrong informations and you revise it many times, that will really give you very different and difficult situations. Okay. So thank you so much, dear children. I'm going to share this video, and then I hope you'll be finding it useful. Okay. So bye-bye.